Good morning, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to be looking at the multiplication algorithm, the standard US multiplication algorithm. But notice that key word is understanding. Now, this is the fourth in a series of looking at the standard algorithm. I've already talked about looking at the addition, subtraction, and division algorithms. And in this one, we're going to extend that to the multiplication algorithm. And in each video, I showed base 10 models that we use to help your children get a sense of quantity. You may see them as a commercial type where it's a 3D version showing hundreds, tens, ones. You may see them as a paper version. And this is centimeter grid paper that I've cut up. The one thing, just as an aside, the great thing about this model is I don't have to put them in place value order for them to maintain their value. Notice I have ones, hundreds, tens. I still know that's 244. Here I have tens, some ones, another 10, and 100. I still know that's 144. Orientation and location doesn't determine value. And that helps us when we're working with your children on learning about the operations and also place value. So I'm going to move these for a moment. And if you want more information about the use of these and the other algorithms, I'll leave a link to the playlist for those standard algorithm descriptions. But again, in each one of those, I talked about a key idea for understanding the algorithm is equivalency. And it's understanding that I can take a number, and let's take a number such as 237, okay? And I can make it with hundreds, tens, and ones. And most of us immediately go to the 200s, 3 tens, and 7 ones, and that's correct. But there are other ways I can make it using hundreds, tens, and ones. I could make it with 113 tens and 7 ones. I could make it with 237 ones. See, there are equivalent ways to make this. I could make it with 23 tens and 7 ones. And a key idea with the other algorithms is understanding this equivalent way to make a number with tens and ones. We use that with those algorithms, is understanding that one of these ways will use the fewest number of pieces. And I'm thinking of these things, right? If I use this way, 200s, 3 tens, and 7 ones, right? I'm using the fewest number of pieces. If I think of it this way, 237 ones, that uses the most pieces. But think about even if I'm making $2.37, there's a way I can make it using the fewest pieces of currency. And then I can also pull out 237 pennies and make $2.37 that way. Now, when it comes to the multiplication algorithm, we'll use this idea also, equivalent ways to make numbers, but there are some other things that are important for us to understand. And there might be some experiences that your children have prior to seeing the algorithm. And that's why you'll see in many curricula, they don't launch showing how to use the standard algorithm for 2-digit multiplication. It comes later because there's some foundational pieces that are very helpful. One thing that you may see is something called partial products. And I hope you see that when we're doing this, we're really honoring place value. We're not ignoring place value. When I learned the standard algorithm, it was all about knowing your facts, and you did not even think about place value while you were doing it. You thought about just those rules. But in terms of understanding what's going on, place value is important. Now, what partial products will do is it will let us actually take the product of each of these components. I've got 7 3s is 21. I've got 7 20s. Notice I'm not doing 2 or 7 sets of 2 10s. Could think of it that way. But 7 20s would be 140. Okay. I've got 3 40s. 120, and I've got 20 40s, 800. Those would be the partial products. Now you may think, why am I doing that? It's much easier to do the multiplication. I can get to the answer faster. But see, these partial products come from understanding that 23 can be thought of as 20 and 3, and 47 can be thought of as 40 and 7. Does this look a little bit more algebraic, right? And what did I do? I did 7 3s. I did 7 20s, right? I did 40 20s, 43s. See, it's the distributive property is just being represented in a way that looks a bit more like our standard algorithm. But this is an important connection, and you may see your child is using this approach before they learn the standard algorithm. Now, I could have gone, and you saw this with the way I just wrote this. You see, when I did this one, I worked right to left. That's what we do with the standard algorithm. But I could have said 40 20s is 800, 43s or 3 40s is 120, 7 20s is 140, 7 3s. See, the order in which I do these, just like the order in which I distribute, will not impact the final product. In either case, I'm going to have, it's going to end up being what? Is that right? Goodness. No, it's not right. You all are looking at the camera going, what in the world are you doing? Does that look better? We've got 8 10s, and then I've got 10 hundreds. Another way of thinking that is 1,000. Okay. Now, partial products, distributive property, that's important. But the other thing that's important for your child to have worked with is notice things like if I do 4 20s, right? I know 4 times 20 in my head if I know 4 times 2, and then just know that's a multiple of 10. I can do things like 40 times 20 is the same as 4 times 2. I know that, but then I need to have each of these, that's a multiple of 100. There's a number sense understanding that goes with that understanding the multiplication algorithm. So there's a lot of pre-activities that can really help your child. Now let's go back, and I'm going to do that partial product again, and we're going to still look at 23 times 47. And when I did it the last time, I worked right to left, 7 3s, 7 20s, 3 40s, and 20 40s or 40 20s, either way. Those were my partial products. Now, when I learned the standard algorithm, I learned it a little differently, perhaps, than some of you. Maybe you learned it this way. We would have said 7 times 3 is 21. We would have written the 1 here and put the 2 up there. 7 times 2 is 14, and 2 more is 16. You would have heard that kind of language. And do you see how I just ignored place value and just went through like every place was the ones place? Now, one thing I want you to notice is what that standard algorithm just did for us is it let us combine those two partial products into one step. That's all we did, right? Same idea. Combine into one step. Then we need to ignore this in this next piece. And I was taught to shift over 1. Now, I didn't necessarily understand why, but remember, these are going to be multiples of 10 because this is 40. But we would have gone 4 times 3 is 12. I would have written a 1 up here, right? 4 times 2 is 8, and 1 more is 9. Now, it would have looked a little funny because all of a sudden I'm seeing 92, but I'm supposed to understand this is 920. See, we didn't think about numbers as whole, we focused on columns. So the standard algorithm, I can teach it in a way that builds understanding. And notice again, this is collapsing into this. I can challenge the children to come up with a way that will help them collapse the two together. And that's a challenge for them. That creates a problem solving. The other side of this is thinking of language, thinking of equivalency, and having a strong understanding of partial products up front. Now notice, I'm going to use place value language this time to do that standard algorithm. 7 groups of 3 ones or 3 groups of 7 ones is 21 ones. What's an equivalent way I could think of it? Kind of like this idea, 21 ones. Well, I could think of it as 2 tens and 1 1. Now, I've got 7 groups of 2 tens, okay, which gives me 14 tens, and 2 more tens is 16 tens. What's an equivalent way I could think of 16 tens? Well, as 106 tens. Do you see I just collapsed into this one step, but I'm thinking place value. I want to keep reinforcing, rethinking about place value. Now, when I come down here to this one, right, this is really 4, I can either think of it as 4 tens, but I could also think of it as 40, either way. But if I have 3 groups of 4 tens, right? So, or 43s, either way, but I'm going to either get 43s, 121s, or 3 groups of 4 tens is 12 tens. How would I think of 12 tens as an alternative way? Well, 2 tens, and then I'm going to have a 100. How I use it in fewer pieces. 40 sets of 2 tens is going to be 80 tens, right? 80 tens, which is the same as 800s, and 1 more 100 is 900s. Okay. It's using place value and the language, but understanding what these numbers actually mean. Now we're back to where I was before. It's just thinking in terms of place value. And notice how I was using the commutative property. I could go 43s or 3 sets of 4 tens or 3 40s. Lots of different ways to think about it. Thinking of this in terms of 40s, right? 3 groups of 40 actually helps me understand why I'm doing the 2 here, or I might even be writing the 0 there. Now, I'll revisit that addition language, but see, I have 1 1 and 0 1s, that's 1. 6 tens and 2 tens is 8 tens. 100 and 900 is 10 hundreds, but I could make that fewest number of pieces would be with the 1,000. Okay, so whether I use partial products, a standard algorithm, but a standard algorithm from a place value point of view is building the understanding. But remember, I need that prior work to understand what's going on when I'm multiplying 4 times 20. Same as 4 times 2 times 10. Commutative property, I can do it in any order. Understanding that when we did 4 times 2, we then were multiplying it by a 100 to get it into the right place value. Okay, so this pre-work is really vital to understanding that multiplication algorithm. To me, it's a little more complex to work out. And actually using this algebraic approach, the distributive property, is much easier, or written this way as partial products. I tend to like to write it this way because it gets me that pre-algebraic approach. I hope this helped a bit with understanding the multiplication algorithm, not just doing the mechanics of it. If you would, if this video was helpful, please give it a thumbs up. Please share it with others who might find it helpful. Please consider subscribing to the channel. It really is important and helps me out. And give the notifications bell a click, and then you'll know when others' videos are coming up. Typically, these are posted on Tuesdays at 2 o'clock Eastern Standard Time here in the US. And so, again, I hope this was helpful. Thanks so much for watching.